Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Now, Dave, what's new in the world of science?
It's an interesting story today, and it appears that scientists some European scientists have discovered what they think is a planet about 7 times the mass of the Earth, which seems to be so light it could be made out of water. So It could be, instead of just having oceans a couple of kilometres thick, it could be mostly water. They've done this by basically pointing telescopes at thousands and thousands of different stars and then watching for stars whose brightness just dips occasionally. And this is what happens when a planet's going in front of it. So if a planet goes in front of a star, the brightness dips a little bit. And from that you can work out roughly how big the planet is. And then they've also got another telescope to have a look at the spectrum of the star. Because the planet's got gravity, it pulls on the star. And you can measure those tiny movements by looking very closely at the spectrum of the star, the colours in the light coming from the star. They can work out how much the star is moving. And so they can work out how massive it is, how heavy the planet is. Between those two, they can work out roughly what its density is. And it seems to be made out of mostly water.
Well, that's interesting. How come they've never noticed it before?
Well, it's actually very, very hard to see planets hundreds of light years away. The technology's only really been there in the last 10 years, and they're only just starting to be able to see these planets which are which are starting to get in close to Earth size, just because it's just so difficult to see, because you're sort of attempting to see a pinhead moving in front of a car headlight, because planets are quite small compared to stars.
Wow. All right, interesting stuff. Let's get right on to our questions now. Now, David in Peterborough says, science, what uses the most electricity? Christmas lights that stay on all the time or Christmas lights that flash, Dave?
Well, essentially, especially the flashing ones tend to be LEDs, so they tend to be very efficient, and they don't lose any energy by turning on and off. So, for a start, they're probably about 8 or 9 times more efficient than a conventional filament light bulb, Christmas lights, the old-fashioned ones. And if they're flashing, then they're only on for a third or a quarter of the time. So that means they only use a third or a quarter of the amount of electricity. So overall, they could be 20 or 30 times more efficient than a conventional Christmas lights. So yeah, definitely the flashing ones and definitely LED ones.
All right, I've learned something now. Hello to Tony, who says, does Dr. Dave think the moon has any effect on us mentally?
Some people think it could be something to do with gravity. It's certainly not anything to do with the gravity of the moon, although it can move big things like the oceans around. The change in gravity on us is about 1 part in 1,000. And I'm pretty sure you might, when the moon's directly above us, we might get a few grams lighter. The moon's sort of right angles to us, we might get a few grams heavier. And I don't think we can notice that. But what we might have noticed and what might have evolved to notice is the fact that when it's full moon, then it's very light, and predators can hunt under a full moon. They've got very good night eyesight. And so if you're a dog or some kind of dog or some kind of cat, a full moon is a wonderful time to go hunting, because you've got the edge, because you've got slightly better eyesight than the prey you're trying to catch. You can creep up close, then you can chase out and jump on them. And so, because we've spent a lot of our evolutionary history as prey animals, as small monkeys, then if it's a full moon, then it's a time to be worried and time to be very aware of your surroundings and not to sleep very heavily in case there's something creeping up on you.
All right. Dave in Great Yarmouth has sent an email. He says, why doesn't the moon come crashing into the Earth, being attracted by its gravity as the moon attracts our tides? And what are the odds of the moon being exactly the correct distance from Earth and the sun to exactly cover during an eclipse? Dave?
First bit, the moon is falling towards the Earth all the time, and it's just falling. Like if you take a ball and drop it, it's falling. The moon is just falling towards us. However, it's also moving sideways. So if you can imagine something falling towards the Earth, but because it's going sideways, every time it should have hit us, it's actually just moved out of the way. So because it's going sideways so fast, it misses. Every time it falls towards the Earth, it misses. And that's what we call an orbit. So the moon is always falling, but it never hits us because it's moving sideways. It's exactly the same way that a satellite stays up. It's exactly the same reason why the Earth doesn't crash into the sun. It's because we're moving sideways. Every time we should have fallen far enough to hit the sun, we miss. Yeah, it is kind of strange that the moon, I think it's actually not exactly the right size to form a solar eclipse. It's within about 5%. So it's about 5%, it appears about 5% bigger than the sun does in our sky. The odds of that are fairly small, and actually through the Earth's history, it hasn't always been the case. The moon used to be closer to the Earth, and as the Earth is slowing down, because of the tides, what it's actually doing is putting more energy into the moon. So it's actually the moon is going higher as the moon is getting more energy and going higher as the Earth loses energy from the tides. I did attempt at working this out, and I think it's a fairly large proportion of the Earth's lifetime. So something like, I can't remember exactly, but it was something like 10 or 15% of the Earth's lifetime. The moon will be in several 100 million years, if not a billion years, the moon will be about the right size. Now, what's the chance of a moon forming to be about the right size? That I would have said is quite unlikely, but not astronomically so.
All right, we've got Robin on the line now. Hello, Robin.
Hello, Sue.
Hello there. You're through to Dr. Dave. What's your question?
Oh, thank you very much. Hello, sir.
Hello.
Sunset and sunrise times and the winter solstice. Now, there must be a good reason why, as we approach the winter solstice, the evenings start getting lighter about 3 or 4 days beforehand, whereas the mornings don't get light until about a week later. Now, there's an anomaly there which doesn't occur at the summer solstice. Is it due to the Earth's wobble?
There's all sorts of things which affect exactly what it is. The Earth does wobble a little bit, mostly because the Earth is pulled by the moon, and that causes it to wobble a bit like a spinning top, and it's also pulled by Jupiter and all sorts of other things.
Yeah.
I think there's also a big effect because the Earth's orbit isn't perfectly circular.
Yes.
So the Earth is actually orbiting on an ellipse. And when the Earth is close to the Sun, it's moving more quickly, and when it's further away from the Sun, it's moving more slowly. And the ellipse isn't perfectly lined up with the seasons.
Oh, it's more complicated than I thought.
So, yeah, the world is always more complicated than you think.
It certainly is, yeah.
Whenever I look into something, I suddenly discover it's 10 times more complicated than I thought it was.
Dave, we're getting lots of reports of snow and lightning. Now, Carida, who's in Leiston, says they've got massive snowstorm there and cracks of lightning and thunder. She wouldn't usually associate thunder and lightning with a snowstorm, but what causes both? And Peter in Woodbridge in Suffolk, says it was snowing, but now it's stopped. Although lightning started, can you explain a little bit more about how this might happen?
Lightning is a complicated thing, and it's actually quite hard to study because it's quite hard to be in. It's quite dangerous to go and actually fly around in a lightning storm when everything's happening, and certainly clouds seem to charge up. A lot of it seems to involve ice, even in the summer, because thunderclouds in the summer are incredibly tall. They're sort of 30,000 feet tall, 10,000 metres tall. And you get very, very strong updraft, and you get water coming up, and then it condenses and freezes, and you get hail and all sorts of things. And then one seems to know that there is actually just one single means of the clouds charging up. Then you get a big charge distribution, positive one end, negative one other end. Then you can get sparks jumping either inside the cloud, which is what's normally known as sheet lightning, or from the cloud down to the Earth. There are various theories about it, some of which seem to involve air passing water and passing ice, and they attract electrons differently. And so it's a bit like rubbing if you rub a balloon on your head, it's a bit like air rubbing across. I think it's quite often hydrometeors, either very small lumps of water or very small lumps of ice, and they charge up, and then they move about and take that charge somewhere else, and it slowly builds up and up and up until there's enough voltage there to jump through the air back again and forming a lightning strike. I've definitely heard of lightning with snow before. It's not.
I haven't. A lot of people are saying, that it's snowing and then lightning.
It's not very common in this country because you need to get lightning. You need quite sort of violent sort of storm air currents and the air rushing past each other. And that's normally associated when you've got lots of energy, and there's normally more energy about when things are hot. But possibly tonight you've got very, very cold air meeting quite warm air, and there's enough energy there to charge things up and actually produce lightning.
All right, well, Derek is in Cherry Hinton. He says they've had 2 small power cuts within a minute of each other. Maybe a surge. Any ideas, Dave?
It could conceivably be lightning somewhere, or it could be some snow building up on something electrical and causing it to trip out.
Mike, who's in Colchester, says, why don't we get rainbows in the winter months? I've seen some rainbows recently.
You do sometimes get rainbows in the winter months. In some ways, I think the real thing is you need a specific kind of weather for a rainbow. You need rain and you need sun. A rainbow is caused because when light shines on a water droplet, it bounces around inside, and when it goes in and out, it does something called refract. This is the reason why if you look at a spoon in a glass of water, it looks bent. When light goes in and out, it changes speed, goes into something which moves slower like water, it changes direction. And different colours of light change direction different amounts. And so each raindrop actually, if you looked at the light coming out of it, each raindrop would produce a kind of a cylindrical rainbow, sort of actually a conical rainbow, lots of cones of different light coming out, and if you projected it from one raindrop, you could see a rainbow. And actually, when you see a rainbow, you see lots of different raindrops in different parts of their cone. So some of them look red, some of them look green, some of them look purple. So you get a beautiful rainbow effect. As I was saying, you need the sun and the rain, which means you need weather which is very, very kind of quite violent, and so ideally you want really heavy rain while the sun is shining at quite a low level. So we tend to see rainbows in the morning and evening because then the sun has more chance to shine through rain. And in the winter, the kind of rain you tend to get is sort of big sort of stratus clouds, so big flat clouds covering the whole sky, at which point they cover the sun and you can't see it, or you tend to get very clear days without any rain. Whereas in the summer you get convection, you get lots of sun, bit of ground warms up, gets very hot, you get it then rises upwards, forms clouds, and then you get very heavy rain, which is perfect for forming rainbows.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Now, Mike in Colchester has raised a good point. He says every year we get snow, we get cancellations for snow on the line, using the phrase, the wrong kind of snow caused delays or cancellations. I wonder, what are the properties of the wrong kind of snow that causes problems on the track? Dave?
Can't say I'm an expert railway thing. There's certainly lots and lots of different types of snow. You can get problems if it's very, very sticky, because it will tend to stick and build up on electrical things. And then if you're not careful, you can then get electrical things arcing out and tripping out because you've just built up a great big pile of snow on your pylon and it shorts out and it doesn't work. I think you can also get problems when the snow is very, very cold and dry. It doesn't stay where it's put and it blows around very easily, and especially if you've got a railway cutting, it can blow right into the railway cutting. I'm afraid I don't know the exact problems with exactly what the wrong kind of snow is, and I have a feeling there's more than one of them.
Let's go to the phones. We've got Kieran there. Hello, Kieran.
Hello. With reference to the wrong kind of snow on the railways, that was used once, many years back, with the advanced passenger train, when they discovered that the grills weren't fine enough to stop the tiny powdery snow getting into the power unit itself. So it came through the grills and it started arcing and interrupting all the electrical equipment within it itself.
So normal snow would have just sort of built up and got caught by the grills, but the really powdery stuff went in.
Yes, yeah. It just, because it was so fine, it was going straight through the grills, not to mention it was interfering with all the advanced tilting systems and the such, because it was designed for sort of like Italy and out of that way of the world. That's where a lot of the technology came from. And they hadn't counted on snow over Hayes Gill, for example. To my knowledge, it's only been used once as an excuse, but it was the sort of thing that was latched onto.
Thank you very much for that, Kieran. Now, from snow to tomato soup, because Derek in Wellingborough sent an email. He says, I've often heard it said, why don't they fill radiators with tomato soup, as it appears to store heat much better than water? Is there any new research in the pipeline of this area? Have you heard about that?
I can guess why tomato soup seems to be a lot hotter than water. And that's because it's got a lot of things dissolved in it. In a similar way to if you add salt to ice, it reduces the melting point, and so it will make the ice melt. If you add salt or sugar or anything which will dissolve in water, it will increase its boiling point. This is why adding salt to potatoes makes them cook quicker. It's not anything which the salt is doing with potatoes. What it's actually doing is it's increasing the boiling point of the water. The hotter the water is, the faster things cook, so it cooks more quickly. And so tomato soup has got lots and lots of dissolved salt. It's got quite a lot of salt in it, quite a lot of sugar in it. So it's going to increase the boiling point. So if you get hit by... So it starts off, instead of 100 degrees C, which boiling water would be, it will probably be at sort of 110, maybe, anything up to maybe 110 degrees centigrade, possibly even slightly higher. And that means it's going to take there's a lot more energy there. It's going to take a lot longer for it to cool down. And also, if it splashes on you, it's going to hurt a lot more because it's a lot hotter. So I think it's probably just that it's hotter. It probably wouldn't have a much larger heat capacity because it's not going to do a lot to the water, and it's just hotter when you boil it, so it stays hot so it stays kind of warm for longer.
Ben, who's 12, who's in Brixworth, he's sent an email in saying, "Dear Dr. Dave, the planet you mentioned at the beginning of the show you said was made out of water. If this is true, does the water evaporate at the core?"
I would have thought if it had been evaporating, it wouldn't stay evaporating very long because water would take the heat away incredibly efficiently. In some ways, it's a bit like if you think of a volcano under the earth. What tends to happen is that, if you've ever seen any pictures of them on TV, you get lava coming out of the earth. It tends to be at the centre of mid-ocean ridges in the middle of the Atlantic, the middle of the Pacific, where the ocean floor is spreading. You get lava coming up. And that's very, very hot, and it causes lots of water to boil around it, and so the water does evaporate. And then fairly soon after that, as soon as the steam moves up a little bit, it gets cooled down enough for the bubbles to collapse. This is particularly the case at the bottom of the ocean because it's under a huge pressure, and the higher the pressure, the higher the boiling point again, which is the reason why pressure cookers make food cook faster, because if you increase the pressure, then the water boils at a higher temperature, and if you're under 5 kilometres of water, then it's going to increase the boiling point quite significantly. If you're in the centre of a very, very large planet, several times larger than the Earth, then I would have thought the boiling point, it possibly wouldn't even boil. The pressure is going to be so high that it would probably go into a different state, called probably a supercritical state, where it behaves a bit like a gas and a bit like a liquid. So it probably doesn't boil at the centre of this other planet, but it could be very hot.
All right, well, anonymous text in here that says, during periods of Earth's history, forests grew and died, eventually producing the coal and oil reserves that we're using today, releasing carbon back into the atmosphere. Does this mean that all the carbon was in the atmosphere at that time, and we are simply returning it, so carbon levels were once much higher than they are now?
There's another effect, which is volcanism tends to release carbon dioxide. So there's a whole lot of carbon locked up deep inside the Earth, which has been slowly escaping over hundreds of millions of years. So that's been adding carbon to the system, and then life has been taking it out very slowly. They think in the very early parts of life of the Earth, sort of just after life had worked out how to photosynthesize and take carbon dioxide out of the atmosphere. The original algae, which learned how to do this, was so effective at doing it that they took out all the carbon dioxide from the atmosphere, got rid of the greenhouse effect entirely, and then caused the Earth to freeze up and turn into a snowball. And then most of the life died, so everything stopped. And then slowly volcanism built up levels of carbon dioxide in the atmosphere again until the Earth warmed up enough for things to melt. And so that, even if we were just releasing all the carbon dioxide back into the atmosphere that it used to be, I think there have been times when carbon dioxide has been higher than now. Certainly billions of years ago, most of the atmosphere was carbon dioxide before green plants developed or green algae developed. But the sun is now brighter than it used to be. So even if there used to be more carbon dioxide in the atmosphere, that didn't mean that it was any hotter than now because the sun was dimmer. And also in fact, things like global warming aren't going to. It's not really save the planet. The planet's going to be fine whatever we do. it's not even really saving life. Life is probably going to be okay. It's actually really saving humans. We don't really have the power to kill off life on Earth. We probably have the power to kill off all the interesting, nice life, which we like looking at, things like dogs and cats and lions and things. And we probably do have the power, and we certainly have the power to change the climate so much that our civilization would break down and life would get very, very unpleasant.
All right, well, that brings me to an email, actually. We've just got time for this. Are humans really at the top of the tree as far as intelligence is concerned, or are we just more arrogant and destructive than most other species?
There do seem to be some other quite intelligent species. I don't think we quite appreciate... I think some of them are a lot more intelligent than we think, although things like people have looked at dolphins and they have quite large brains, but actually if you look very closely at the brains, a lot of that brain is actually specialised nerve cells for keeping the rest of it warm, because they swim around deep in the oceans, which is very, very cold. So quite a lot of dolphin brain is actually sort of radiated to keep them nice and toasty and warm. But I mean, I think there's no evidence for any creatures to be as intelligent as humans, certainly. But the real killer that humans have is our ability to manipulate things, be intelligent and manipulate things with our hands, so building tools. And whilst there are other creatures who do build tools, certainly not on the same scale as humans do, which is the reason why we've seemed to have taken over and causing quite so much chaos.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists comes to you from Cambridge University and is supported by the Wellcome Trust, the EPSRC and UK FAST. For more information, look us up online at nakedscientist.com.